About 1 more minute. Another minute, we're gonna get started. We've answered at least one of the 2 questions right now. And all you gotta do is share your screen once the clock expires, so you can see how far you've gotten. Well, you can if you want to now. Share your screen. And then we come to you, Carson, when she's done. Share your screen, then click on your document tab so I can see what you got. All right, so first up to bat is Ashley. Okay, and let's take a look at what she did here. All right, so let's grab this. All right, Ashley, can you zoom in some on that screen? You know how? Yes, there you go. Bring it up some. Okay, so let's start with her first question, all right? And she said, series parallel circuit or combination circuit combines both series and parallel connections. Most electronic circuits fall into the category series parallel circuits are typically used. Wow, Ashley, you did a good job on this one. And the other one you said, okay, so does current stay the same in the combination circuit? Current outside the branches of the combination is everywhere the same. Current inside the branches is always less than the outside the branches. When comparing the current of the 2 parallel connected resistors, the resistor with the least resistance will have the greatest current. Very good, Ashley. You can stop sharing. You got 15 additional points. Make sure you add that to your score. Mr. Tyshawn Carson, you're up to bat next. Waiting on Tyshawn. Okay, something's popping up. You're the man. Okay, so sir, there we go. All right, so it says here, series parallel circuit or combination circuit combines both series and parallel connections. Okay, and then he goes on in part B, the current outside the branches, like what Ashley had a second ago. But the same thing. All right, 15 points, my man. Good job. Add it to your current running score. You can stop sharing now. We went up to the top. You guys document established. Okay, so now you know what time it is. We need to just drag this over here because we know what's going on. We need to now jump into our simulation section. So quickly find that link, right? Because you're going to need that to do the simulation with me. All right, so I'm going to go ahead and let's see here. Click next. Here's your exit slip info. All right, anybody want to read this for 10 points? This is just what you will do at the end. Last 5-10 minutes of class. Anybody want to read it or no? Okay, she looked over at you. You're on your thing. All right, so I'll read it. So exit slip for today is class return today is a combination circuit. We kind of talked about that a little bit. We're going to see it with the simulation. Word of the day is critical thinking skills. Very important. Make sure you have a sentence and definition for both. Yes, those 3 words are one word in my mind, as far as a concept. So the objective for today, students will be able to mathematically simplify our multiple resistor combination direct current, basically a circuit, DC circuit, into their respective equivalent resistance. And we're going to just basically take this big circuit that I'm going to show you, and we're going to squeeze it down to just one resistor that can do the whole job. All right, so let's go to our next part. So we're going to stop there for a second, and we're going to jump into the actual link. If you go inside of EDSB, you will see here there's a link in today's assignment. For you, Ashley, it's a message. Dr. Ortiz, he indicated that your class for this, your name should pop up in this class, and you'll have access like Tyshawn Alika does. All right, so you bringing them back? Okay. Is he all right? Oh, he's trying to get away from you. Okay. You bring the computer, Angelique. Right. Anyway, so not that important to you. Okay. All right. So I'm gonna go ahead and copy. This is the wrong class. Come on. So you go to robotics. All right. And then we're going to see the first assignment I posted today, combination special. Let's name it a problem. And click on that. It takes a second to load. Okay. Let's put that there. Okay. All right, hit play. All right, now pay attention. I'm going to give you a heads up on what circuit you're drawing. I'm going to put it on the whiteboard up here, and you're going to redo what I do. It's located on page 763, I think. So open a book if you don't know what you're building. If you can start building before me if you already know what you're looking for. You open that book, actually, you know what's going on. So if I turn to page 763, which was pretty much in the notes, look at that diagram, and the name of the problem is combination special. We're going to recreate that in our simulation with 2 additional resistors, okay? 763, look at the top. You see that circuit? Not in the practice problem, but in the example problem. So it looks like this. All right? I'm going to recreate it on the board for you. Of course, you know that little epsilon means what? Right, it's the battery. You know where that goes, right? So remember I told you in blueprint mode you have a resistor like this, right? You come down, huh?
You can make it?
Yes. I say you can make it, but I'm just drawing it out in case you don't know what I'm talking about. So these little squiggly lines are resistors.
So the straight line is just what?
Wires.
We're in intro and lab.
We're in lab, so you get more tools in lab. Okay? So now I'm going to connect these parts, these junction parts like we did. And you have to connect it the same way, right? So if I come here, there's no resistors. This makes it super easy. It's just 3 resistors. Now I'm going to put my electromotive force here. It looks like this. Right? And this is epsilon, or electromotive force. This could be considered your R1, your R2, and your R3. Okay. Keep that in mind. So let's look at the book. Let's look at the problem, right? I gave y'all a problem in ESG. So let's go to ESG real quick. That's a great question. I'm going to go ahead and click on this so you can get ready for me. And if I go back to the actual problem, our resistance was for something, I think, right? There that is. So if I look at the problem, we're looking at about, let's try to get it close to 555 ohms, okay? 555. Is that the same as our we do? Yes, it is. So we know each resistor has to be 555 ohms. Each resistor. So you can use your 1,000 ohm resistor, right? So let's do that. The goal is 555. So let's rewrite the circuit, right? So I'll make this first box up here. So that's a wire there. I need my high-powered resistor. If you can't see what I'm doing, go to Google Meet and click on my screen, and you should see what I'm doing. All right? So what else do we got here? I'm just doing the top part, if you notice. A wire, because I'm doing R1 right there, right? Okay? So far, so good. We'll make a nice little turn here. So you can see how I do that. And I'm not going to make it too long because I'm going to make another junction point. Make a wire come out. Bam. Leave that there like that. And then another wire and connect that there. Okay? So far, so good. Let's do the same on this side because we're going to make a box out of this. Okay. Snap in place. And then again, don't go too far because you want to make a junction, a turning point, because you're going to make 2 circuits inside of a big circuit. All right. Everybody see how I did that? You got a junction point. All right, continuing on, we're going to connect this, but we got 2 resistors to put inside. So don't make the wires too long in there. Grab the same resistor. You got to stretch this side out, right? There we go. And another resistor. The middle, just clean it up. Resistor wire connection, boom, boom. That's R1, R2, R3. And we're going to change to 550 each, or as close as we can get to the same thing as a problem. All right, so far so good. It looks very beautiful. All right, now we got to finish the circuit off. All right, I've done the top part, as you can see. Now I got to come down and do this bottom part to connect to our electromotive force. So I just come over here and grab some wires. And you want to, connect the wires like junction points. Okay, another one. Connection, another one. All right. Before we get too far, we're going to put a bulb at the end. All right. So I'm going to put a bulb down here somewhere. Stop there. Connection point here. At this part, we're going to put the ammeter so we see a current. And we're going to put a probe up here to see how this current is working. All right, so this is for the outer circuit. This is for the inner. We need, of course, before we use our light bulb, put a fuse in there. Okay. And then a wire over here. And right before the wire connects to the battery, let's put a switch in there so we can keep this circuit safe. So grab a switch, snap, wire, there we go, getting close to the end, just move this over some. Still got a lot to do. All right, so your switch is right dead smack in the middle. All right, now I'm gonna grab a high-powered battery. It's the one with the lightning bolt on there. Connect that. And then right before we finish, let's stretch this out some, we're gonna put a light bulb in there. We need a real light bulb, so don't forget to click on advanced and values. You can see everything you're doing. This recording will be available later though. We're gonna rotate the bulb. Remember I told you at the very end you're gonna have a light bulb connected, so let's put it right here. Snap, snap. Now I'm very curious how this is gonna go because this is right by the light bulb, so it's not a lot of resistance, right? So who knows if this will pretty much explode, because there's no resistors in that series circuit there, but the resistors up top. So give it a moment, play with it. I'm not going to turn mine on, but who can tell me what is it going to do? And if you can, for additional 5 points, making 10 points, how do we fix it? Where do we put the bulb at instead? All right, so come over here. She's doing good. She's on her circuit. And again, you guys can switch between Google Meet if that's not visible. You can see on your screen too. Okay, what up, you, sir? You blow up your circuit. You blow your stuff. So you got smart. He didn't pop. Right? Because he's at 4 amps. All right, so everybody's pretty much almost caught up. Carson's got it all the way. And like I said, I was trying to see if it was going to blow up. But if you notice, our fuse is rated at 4 amps. So nothing wrong because you only got about 60 amps here. All right, now we have to change these resistors, right? Remember in the problem, it was 555 ohms. That's for every resistor. So click on this and then change it to 550 or 555 if you can. So looks like I'm getting, yes, all of them have to be 555. Let's put 560 for each, okay? Because you can't do other intervals of 5. Come down to 500, and then I'm going to go to 560, use the arrow, and the same thing with this one, and come down to 560. All right, so you should have 560 on all of them. Let's do our final touches for our screenshot. So I'm going to grab my voltage meter, and what I want to test is how much voltage is coming off the light bulb. So I'm going to bring the voltmeter over here instead. Red lead goes right here on the first connection point of the bulb. The other one, black lead, goes right here across the bulb. All right, now it looks like the leads are in reverse. Huh? I put it on the bottom connection point for the bulb. All right, so you see that's negative 728. 727.78. Just want you to see that there's a lot of voltage right there and it didn't explode. But what about the voltage across the entire circuit? So now I'm going to put this right here, okay? So I think right here to over here, I want to say. And you see the total 1,000 volts. If I put it here, right by this one, still got 1,000. Put it over here, you still got 1,000, all right? So this is 729, it changes. So let's put it right here and right here. And then we want to see the current inside the inner circle. And you notice they're different. This goes back to the question that you and Ashley answered earlier. Okay? So I think we're about ready for our first screenshot. We got everything we need. Does everybody have this set up? Because I'm about to do one change to the circuit. I'm going to turn it to conventional for our second one. And let's see, labels. Did you click on labels? Make sure you turn the labels on. All right, now, does everybody have this? This is your first screenshot. All right, take your screenshot. You come down here, click on the FET logo, and screenshot. All right, second screenshot is simple. You're going to click on conventional. This is the engineering or technician version. And then, of course, blueprint mode. And it looks like the circuit I have on the board behind me now, with some additions. Take your screenshot and let's get ready for our We Do Next. This video, again, will be available later. So tell Alika that when she comes in so she'll know how to redo it. Everybody got their screenshots?